Hello everybody, let's get started. On Monday, homework 12 is due, so please feel free to stop by today if you've got questions on that assignment. We're going to be continuing to talk about payback analysis today. It's something that we've touched on before when we did the unrecovered investment balance progression on the spreadsheet, so that's sort of more of what we're going to be addressing today. Any questions before we get into it? All right, so just to set the stage, let's consider a what if. What if you were in the construction business and you were thinking about buying a new piece of equipment, just for example, a steamroller. So if you were buying a steamroller that cost $78,000, you could either pay for it out of your existing holdings or you could take out a loan, but there's some sort of a discounting factor that accounts for the fact that the revenue you're earning in the future is worth less than the amount you're spending today to buy the equipment. And just as a hypothetical, let's say that you had a construction equipment loan that was 7.5%. And by buying this new piece of equipment, after considering the cost of operation and the cost of maintenance and fuel and so on, that your net revenue is $16,000 per year. And so you're going to be making money over time, but the question could arise, how long is it going to take before that was a wise investment? We haven't looked at so far how long the equipment lasts. What if this equipment was only good for 2 years? Would it be a wise investment? Definitely not. Not for 2 years worth of revenue, because even if you're ignoring the fact that money in the future is worth less than money today, 2 years at $16,000 is not going to cover the $78,000 that is required to purchase the item in the first place. And so the analysis that we're going to be doing today is looking at something called the break-even point and comparing it to the useful life of the equipment. And we've done something similar to this before. This is a screenshot of a spreadsheet I showed you in one of our earlier classes, and a diagram that I hope if you had it on an exam you'd be able to explain what's happening in this diagram. Where on the y-axis we have an amount, on the x-axis we have time, and the interpretation of this is that when you first make an investment, when you first purchase the steamroller or sink a bunch of money into your company for some sort of improvements, then you have an unrecovered investment balance. And even though it's costs up front, we're putting this as a positive amount because by definition we're saying an unrecovered balance. So we already know that it's an expense that we've incurred, so it's negative money, and by stating that, it makes it okay to put it as a positive amount on the y-axis. And so over time, remember, when we saw this before, we had the amount getting higher during the year. Why is it that this blue line has the curve that it does? What's causing the unrecovered amount to get greater? Interest. Right, so we made an investment, and we should always be looking for a return on our investment, but the amount is getting higher, the unrecovered amount is higher until the revenue for that year comes in, and that retires some of the unrecovered investment balance. And so in the previous in-class exercise and homework that you completed, you were trying to find out how long did it take until the balance went down to zero. And we're doing a similar thing today, except for that we're applying it to analysis. And we're using it for decision making, choosing from among alternatives. And I'm going to show you a new Excel spreadsheet function today that can calculate the amount of time very, very quickly and in an automated way. We can still use this approach to find out what's the unrecovered investment balance at the end of each year. That'll still tell us how long it takes to get to break even, but there's an even more simplified way. Before we get into that, let's consider some new terminology. First of all, we're going to call N sub P the payback period. And what that means is how long it takes to pay off the equipment that you've purchased, or how long it takes to justify an investment when you have known revenues, or they could be cost savings, which we consider as revenues. When you buy some equipment that saves your company money, for example, if they got a new heating and cooling control system for this room, so that this side wasn't on AC while that side was on heat. Sometimes they fight, the two sides of the room. I've come in here before when that side's been on heat, this side has been on AC, and it's like they're having a battle. So if they invested in a new system that made it so that they were somehow synchronized, that would result in cost savings to the university that you can consider as a revenue. Well, we can calculate how long it takes to pay back that item for the interest that we use and for the revenues and the savings related to the costs. Now, simple payback is not what we're interested in. If we go back to the steamroller example, it would be almost meaningless for us to say 16 times what equals 78,000. 16,000 times what equals 78,000. Because if we did that calculation, it would be ignoring the interest rate. And so we do have to consider the time value of money. And so it's very uncommon that what we'll do is simple payback. Simple payback only applies if you have a zero interest loan. And that's rare, but it's not unheard of. Sometimes car dealers will offer a 0% loan, or the government may very occasionally offer no interest loans to stimulate something. But more commonly we'll have discounted payback. And what discounted payback is, where we are accounting for the fact that the revenues in the future have to be reduced or discounted to bring them to the present because of the effects of inflation, meaning that money in the future is less valuable than money today. Payback analysis we can use as an initial screening tool, and the criteria that we should apply is, will the equipment last longer than it takes to pay it off? So the steamroller, if it takes us 10 years to pay it off, then we want to make sure that the equipment is expected to last 10 years or longer. And so the first rough draft is the screening tool. You can also use it for choosing between alternatives for comparison. But we have to be careful. You know how sometimes there are tricks where, like B2C analysis, if you're just looking at the benefit to cost, it's not always the one with the best B2C ratio that's the best alternative. In the same way that we can't compare internal rates of return. Remember where that was a warning I gave you that don't just pick the project that has the highest internal rate of return. What was the project that you wanted to pick instead of the one with the highest I? What was the rule I gave you back then? You'd either pick the one with the best incremental internal rate of return, comparing that to the MAR, or whatever project gave you the most profit. Maximize profit, not maximize interest rate. So here, it's a similar thing where we have to be careful. The quickest payoff time is not always the best equipment. If everything else is equal, like if two different alternatives are the same cost, then you'd want to find out which of them can have the fastest payoff time. But often we won't be comparing alternatives with the same initial cost, and so you can only use this payback analysis as initial screening and as a careful comparison tool. So here's the warning. The payback analysis doesn't look at payback, cash flows after the payback period. And so you may have a piece of equipment that lasts for a very, very long time, and even though it takes longer to pay off, because it lasts so much longer, it may ultimately give you the best present value of the profits. So we'll, in our illustration for the in-class exercise today, we'll face a situation where we have to apply that warning, just so you can be aware of the limitations and the implementation of payback analysis. Any questions so far? Okay. So here's what we're going to be doing. The first part of today's in-class exercise we're doing with paper and the factor table that's on the back of the handout. And in the problem statement, what it's telling us is that there's some equipment that has a present cost and it's going to generate an annual net revenue. By net revenue, what I mean there is it's the expenses of operation subtracted from the additional revenue that's being generated. So it's sort of like the extra money that's coming in by putting this new equipment into place. So what you're going to have to do for these factors is compare on the back of the page there the P/A table, or A/P, to find out how long is it going to take to pay back the initial cost. Because what those tables tell you is the ratio of A and P. So let me draw on the board what I mean. In the in-class exercise, it says that we have a present cost P of $92,000. And the A that we have, the revenue, is $11,000. All right, so now turn to the back side of the page there. It's the 8% table, which is the MAR for our project. We have a column that is P/A, and we have another one that's A/P. We could use either of those. What we're trying to find out is what N corresponds to either the P/A or the A/P that we get with these numbers. We can construct our own A/P, and what that's going to tell us is how many years it takes of $11,000 in revenue to justify $92,000 in present costs at 8%. So that's what you should do in step one. Use those lookup factors, and then if you have Excel available today, create a spreadsheet where you have the following column titles, where you've got year, amount, PV of amount, and unrecovered investment balance. Okay, so we're going to have an interest rate of 8%, and then our column titles are going to be year, amount, PV of amount, and then the unrecovered investment balance. That will confirm what we get from the table lookup factor. So let me give you a moment to figure it out, first of all, with the table lookup factor approach. Okay, so let's try and do the first part of this. In the table lookup factors, finding the P/A for a certain N value and an I value. Okay, so for us, we have the P is 92,000, and if we divide that by 11,000, then just using the calculator, we can get that that value is 8.364. Now, if we go to the table lookup factors, here is some table lookup factors for P/A. You can see that for 2 years, we're only up to 1.7. What we're looking for is how many years is it till we achieve 8.364. So if we go down through this table, we're looking for where does it cross over to 8.364. Well, it's never exactly that. What it looks like is it's between 14 and 15. Okay, so somewhere between the 14th and the 15th year is where we actually pay off the equipment. And we can do the same kind of idea. We can verify that in Excel by setting up the unrecovered investment balance as an illustration. So we're going to go through 20 years just to look and see where things are at. So we've got through 20 years. Now, at first we have the investment of 92,000, and then every year we have a net revenue of 11,000. And that same 11,000 is coming in every year. We don't know anything about how long this equipment lasts. All we're really looking for is the crossover point between a negative investment balance and a positive investment balance. So now we're going to do the PV function to find the present value of these amounts. PV Our rate is 8%, so I'm anchoring the reference there. N is the year, skipping over the payment field to the future value field and doing the negative of the amount. All right, let me format that as currency and reduce the unnecessary decimal signs. All right, so I'm going to drag that down to see what is the present value of all this revenue over time. And as we expect, the future money is worth less than money that's closer to the present. And now the unrecovered investment balance for the first year is just the $92,000 is what we've got outstanding. But then we've got some revenue coming in at the end of the first year. So it's going to be the previous unrecovered investment balance plus the amount that's inflow for this year. So gradually it's going to go from negative to positive, and what we should see, if our previous calculations are correct, is that it should cross over from negative to positive between the 14th and the 15th year. And so it matches what we saw from the table, which is here in the table we saw that it went, we were looking for the ratio of the two, 92,000 to 11. The ratio is 8.36. And so here on the P/A table, that is between 14 and 15 years. Okay? So I'll give you a moment to do the unrecovered investment balance. But let me show you the NPER. It's a beautiful thing. It's very nice. It'll save you from having to do the unrecovered investment balance if all you want to know is how many years it takes to pay something off. So I'm going to have just a cell where I do this calculation. I'm going to label it as payoff time. So it equals NPER. And then starting the parentheses, it's going to start to prompt me to remind me what I need to type in. So the first thing it wants to know is what is the interest rate. So I can just click on the cell location. I can anchor if I want, but I don't need to because I'm not going to be applying this formula multiple times. I'm just going to be applying it once. Okay? And then a comma here. And now it wants to know what is the payment. And so it means payment is a recurring amount that you get more than one of. And so the payment that we're receiving is $11,000. So I'm just going to type in 11,000, comma, and now it's asking what is the present value, meaning how much did you put in at year 0? And in our case it was negative 92,000. Now I'm not 100% certain about the signs here. Let's see if it gives us the correct answer with the revenue being positive and the cost being negative. Type enter. Yep, 14.4 years. And that's very simple, right? That's a lot easier than doing a column with the PV of amount, doing the unrecovered investment balance, and finding out it's somewhere between year 14 and year 15. So that NPER function is, it's in some ways similar to the NPV function, where it's doing a lot all at once. It's finding the payoff time, essentially. All right, part 2 of the in-class exercise is kind of next level. What we've got is 2 pieces of equipment, and what I'm trying to do with this comparison is remind you of the warning. The warning is that the shortest payoff time isn't always the best equipment. The best equipment is the one that gives you the most profit. We should only use payoff time as an initial screening tool, where the criteria is reject the item that has a longer payoff time than useful life. So here we're comparing 2 equipments, and machine Y is a little bit strange. For whatever reason, its revenue is increasing in the later years. Maybe it's something like it has some sort of an equipment of like part of what it can do is only going to matter in years 6 through 14. Or maybe something about it is in the first 5 years it's not going to be able to generate as much revenue. So you can use the NPER approach for machine X to find the payback time, but you can't use it for machine Y. You have to do the unrecovered investment balance to find how long it takes to pay off machine Y. The NPER function won't work for machine Y. So find out what is the payoff time for both of those items, and then, at first glance, one of them will look better than the other, but then on closer inspection, when you do part B and actually calculate the present worth of each alternative, what you'll find is that actually the one with the lower payoff time isn't the one that gives you the most profits over the long term. So we'll talk about why that is and look at the numbers in just a moment. Okay, so at first glance, it looks like machine X is better. At first glance, though, it isn't actually. It's deceiving. If we look at the payoff time, machine X, after 6 years, the item is paid off. You're almost paid off after 5, but you're still not quite there yet. You have to actually do the 6 years before it's paid off. Whereas machine Y, you're not paid off until after 8 years. And so machine X pays off quicker, but the problem is it doesn't last as long. So here in part B of the in-class exercise, it's asking you, based on present worth, which machine should be purchased. And here's what we know about present worth, is that to compare them together, we have to repeat alternative X another time. So I'm going to create a copy of this. And so in year 7, it's going to be the 3,000 in revenue, but then minus 12,000 because we're purchasing the item again. And then we get 3,000 in revenue for the years after that until the end. And so what we could do is just calculate the NPV. Here's our cash flow amount for each of the alternatives, alternative X and alternative Y. So here's NPV. Let me do the formula. Equals NPV. The rate is 8%. And then the range that we do is just the amounts in the future. And then we're going to combine that with what's already at the future. So 5730 is the present value of alternative X compared to, at 8%, these future amounts only, an external of the NPV function adding on the amount that's already in year 0. So alternative Y actually is the better choice because it's more durable. Because after it pays off, it's generating so much additional revenue compared to alternative X. So sometimes people take the short view and they just say, what equipment can I pay off the fastest? But that would be a mistake because our objective is to maximize profits, and maximize profits are going to be the one that isn't necessarily the one that's paid off fastest, but the one that gives you the best present value of the revenues over time. So that's kind of the main idea of the in-class exercise here is if we take a look at the key, I thought I wrote it on there, no. So the payback time should be 8 years for alternative X, because it's not, 6 years for alternative X and 8 years for alternative Y until we're in the positive territory, but then in the present value, alternative Y is better. All right, so that's it. Just as a reminder, you've got a homework assignment due on Monday. I've got office hours now, so if you've got questions on the assignment, I'd be happy to see you. I'll be in the office for much of the afternoon, so even if you can't come see me until later, I'd be glad to see you, and that includes if you've got questions on the project. So have a good weekend, and I'll see you on Monday.